Every so often, I get slightly frustrated with writing something in Go because Go doesn't have generics. And when I do that, I find myself constantly Googling Go generics, just like I've done here. And I've been doing this, for a few years now, hoping that the proposal or the request for generics has progressed. And recently, when I did Google, maybe a couple of months ago, Go generics, I got this top result. In about June of 2020 this year, I saw the next step for generics, which was very, very exciting. I'd seen the previous proposals, was happy that there was progress, but I was especially excited by this one because I saw the header experimentation tool. Finally, we'd be able to get a chance to have a play with Go generics. And what I wanted to do is to play with Go generics and kind of work through them with you a little bit. I'm not going to go through the full design draft. I think we'll cover the fundamentals as we get going. But I think we should just dive in and have a go. Pardon the pun. But for those of you who aren't really sure what generics are, what they can offer, I thought that first of all it might be helpful to explain them by using another language, which in my opinion does generics very well. And for me, that's TypeScript. I generally don't see the point of TypeScript. If you wanted to use a typed language, use a typed language, and if you wanted to use an untyped language, use a scripting language like JavaScript. I don't really see the point of making JavaScript strictly typed with TypeScript. I'm not sure. So, but that said, TypeScript does do generics very well, and I thought that it would be useful to first demonstrate in TypeScript how generics work and what they allow you to do before we move on to Go and the problems that I think generic can really solve in Go. So when you're writing functions which are strongly typed, that makes them restrictive. You can only use them with a particular type. An example of that, which the poignance of this example will become clear shortly, is in something like the example of getting keys from a map. So let's say we have a map. We want to get the keys from it. Just extract the keys from the map. What we'd have to do what we would have to do when we define this method to get these keys is define the type of the map. So define the key type and define the value type, something like this. And then we have to say, well, we're going to be returning strings because the keys are strings. Sorry, that's not the correct syntax for that. There we go. And in fact, it will be an array of strings. And in fact, this is now not a get map keys method, is it? It's get a string map keys method, because it only works for maps which only use strings. So we can create a map, something like let's make our string map is a new map. And you define its type like this. You say string, and we have a string map. And now we can implement this. So we can define our array is something like this. And then map does have a for each method, which gives us the value and the key. So we can just push the key and then return the array. And this works just fine, and we should be able to get our string keys by calling get string map keys, passing in our map, and then we can just log those I think we get the logs over on this side. Where do we run it? We run it here. I'm going to make this a little bit bigger. I'm not sure if that's big enough for you to see. Hopefully that's a bit bigger. We got empty because it has no keys. So let's. It has no values in there. So we can add some, like we can say hello, goodbye. I don't know what else. We could, sorry. Hola, adios. And now when we run this, we should see on the right hand side here, yeah, you see we got the keys, hello and hola. But if I had a different map, for example, it was, let's say it was an ID lookup. So we wanted to have ID lookup, and it would be a map of integers, say our IDs are integers, and it's going to be to a generic object because that is our users that we're looking up. Sorry, not integers, numbers. So let's say it's an ID lookup, like a some kind of in-memory database where I'm going to look up an ID and get back an object for, say, a user. If I wanted to get the keys of all the IDs, I can't use this method because it's specifically for maps of strings to strings, and that's not what we've got here. And you'll see if I try, even though all the methods should work, and you'll see that if I try and use this method with our ID lookup, I get an error because this is not assignable. This map is not assignable to this type of map. So what this would force me to do is implement a whole other version of this method for this kind of map. And then if I have a third kind of map, any kind of variant other than string, key, string, value, I have to re-implement this method. And that's a pain in the arse. And it's going to result in loads of code and loads to maintain. It's nonsense. Fortunately, TypeScript has something called generics, which means that I don't have to strictly define what the type is that you have to pass in, as long as we do define it in some algebraic way. And I'll show you how that works. So the method also takes type arguments, which we could call key and value. Okay, these are just type arguments. So they're arguments of a type passed to this method. And then we know that our keys are going to have type key, and our values are going to have type value, because that's what we're defining them as having. And we're going to return an array of the key type, because that's what type our keys are, if that makes sense. So now we need to define this array as the key type. And now this should work for any kind of map, because it's algebraic. So when I pass in a map of type string, string, this key becomes string, this value is the value type. Those are defined by what our arguments that we pass in here. So when I pass in a map of type string, string, key is set to string, value is set to string, and we know therefore that that key type is what we're going to be returning an array of. But equally, when I pass in number object, this key type is set to the number type. This object is set, so the value is set to the object type because that's what we're passing in. Again, we're returning these number types, which is what key is set to. And this array is the same here. And now this works. So you can see that if I say number keys, I can log this. And if I run it, yes, I didn't add anything, but so let's say .set this ID is of type name Jane, and this ID is for the username John. When I run that again, you see we get the keys. It works perfectly well. So what we've been able to do here is define a single generic, strictly typed but generically typed method. So this method works for any typed map and is able to get the keys for it. So we still get type protection. I can't do anything crazy here, like, for example, I can't assume that let me see. I can't assume, for example, that an element has this object because that's not defined on type key, because key is still strictly typed. We know nothing about this key value, so we can't guarantee it has that property. So this is the beauty of generics, that we're able to be generic while being strictly typed. And that is what would be so useful in Go, to maintain the strict typing, but not having to implement this get, for example, this get map key method numerous times. So let's take a look at how that might work in Go too. So let's delete everything here because we don't need much of this. We don't need this method. But let's think about that same get keys method again. So on the get keys method, it's going to take in a map, and remember here we're going to have to define the type of our map ahead of time. So define that as keys. And then we can just range through the map. So this should work, right? But for string maps, so we can say map string, and then we'll say hello, goodbye, and then hola, adios again. And it should work for our, provided I've done everything correctly, string map, and then we can print string key. So this should work for our string map. You can see it's managed to extract keys. But if I had a different kind of map, for example, our ID lookup again, let's say it's an integer to just an interface for now, whatever. And I can say let's just pretend that's user 1, whatever. And then, oops, let me replace the 0 at the start of that. I can't use get keys for this map because it doesn't map to this type. It's exactly the same problem we saw in TypeScript. But just to prove it, we all know that this isn't going to work. You can see, ID lookup doesn't match map string. And this is a constant problem in Go for me. I'm always writing methods which I wish were generic. For example, I had this very problem recently, and I had to implement several versions of the get keys function. But Go generics are here, and we don't need to anymore. So this playground, like I mentioned, is running Go generics, and we can give it a try. So just like TypeScript, we can take a key type, or we can call it anything. So just for clarity, this can be, the T and U can be anything. Now Now here you have to define inside these square brackets for the method the constraints on this type. So does the type need to have any kind of property? For example, this can be an interface type. It needs to have a specific interface or something like that. And there's more to be said about constraints that I won't cover here. But keys, map keys, have to have the comparable constraint, and that simply means that they can be compared like for like. For example, strings and integers, these can be compared like for like. To be sure, rather than say pointers to objects or something like, or other types, those can't be the key in a map because they can't be added to a hash map. So therefore, the key does need to be this comparable type. But after that, it works exactly the same way. So now we can say that as long as our map has type T and the values are of type U, then we know that we can return these keys, which we know will be type T. So it's a slice of type T, and everything else should work exactly the same. So let's see. So we should get int keys here. And we'll print them. You can see that it worked. So now we've got this generic method written in Go. And I think this example, simple though it is, demonstrates an incredible power to generics in Go. And there's a reason why people have been asking for this for such a long time. Because being able, and let me just make this too large in case you can't quite see, being able to maintain these strict types while keeping generic, while defining generic methods is going to be incredibly useful, especially in Go. In languages like TypeScript, where the JavaScript types all have utility methods, it's actually less useful. But I think defining these utility methods in Go is incredibly powerful. And to demonstrate that, let's have a look for a moment at a separate example. For a long time, I've wished that in Go there could be a map function, which would just take an in and out type, right? It would take an array of inputs and a mapper function which would iterate over those inputs and map them to some other value in some way, and do this generically. So what I'm going to do is try and build one of those here. So we take this array of inputs of type in, and we accept this mapper function, which takes an individual in type and the integer. Well, let's not worry about it. It could take integer as in the index in the array as well, but we don't need to worry about that for now. Well, let's do that just so that we can demonstrate it. And it would return type of type out, type output. And then we know the return types can be strictly typed as an array of these outputs. So then all the map function would do would be to range over the input, range over the ins, get a result from the mapper function, which would take, so we're going to give it the index because that's often useful in mapper functions, and then append to the output. And it's pretty much as simple as that to implement a generic map function. And a couple of examples, let's think of a couple of examples. Well, the obvious one is, say, a doubler. So let's say we have some numbers, for example, we have an array of integers which we want to double. and we could have this doubler function which takes in the number, which is an integer, and also takes in the index because we're going to pass that in here, right? And they're both type number, and we're going to return an integer as well. And then we just return num times 2. So now we can use this mapper function to double every element in this array here without any more work, because we've defined this utility method already. So we can say that the doubled are pass in nums, and we pass in the doubler, and then we can print doubled. And our mapper function has effectively done that. But to prove that this is generic, let's think of another one. For example, imagine we have an array of sentences. So let's say we have an array of hello and welcome, generics are cool. So we have an array of sentences or an array of words, sorry, an array of phrases. And now we want to get the length of each one. So all we would have to do for that is define a sentence length function, which would take in a string and remember our index, and return an integer, which will be the length of the string. Again, we have this utility map function. We just pass in the sentences, and we pass in the sentence length, and we should get an array of the lengths of all the sentences. There you go. And of course, you know, in more like the JavaScript style, you might define this as like a callback type here, where you can actually define the sentence method just in the function. When you're doing, you know, JavaScript, you usually just define the function here. So just to demonstrate how kind of idiomatic this is, even for a JavaScript programmer, how nice this is that we can pass in a function of very different types, you know, of accepting integers for accepting strings into this generic map function and get the result that we want. So I'm not going to go too much further. I think you get the picture hopefully now of Go generics, what they can offer. I think this is one of the most exciting, well, really the only large change since Go came out in terms of the language itself rather than just the ecosystem. And I cannot wait to have this to work with, to use. I think they've done a fantastic job of putting this spec together. I think it works really well. It's not too verbose. It works brilliantly in Go while being very similar to other generic implementations in other languages. So with that, I'll end here. Thank you for watching this far. Let me know your thoughts on generics in the comments. Always happy to hear your thoughts. Do you think this will be useful for you as a Go programmer? What other languages do you use? Do they have generics? And do you make use of them? Give it a thumbs up if you're excited for Go generics as much as I am. And please subscribe, because I'll be putting out plenty more videos about Go, about software engineering and distributed systems in the coming weeks and days. So thank you for watching, and I'll see you soon.